Okay, this is the oxidation reduction practice in the final exam practice, and I'm going to go through and just skip around and do a couple of problems, but all the answers are given to you in the practice key here, but I'll go through some of the steps and a couple of the more difficult ones. So zooming in, let's start with number 3, and let's go through the steps to assign oxidation numbers. First of all, potassium is going to be +1 because it's in group 1 on the periodic table right here. Anything in group 1 is always +1. MnO4 is actually a polyatomic ion you memorized, and it's on the back of the periodic table here, and it's -1, but we want to split it up, and so you could do it 2 different ways. You could say that oxygen is -2, and if potassium's +1, manganese has to be some charge, plus -2 times 4 has all got to add up to equal to 0 because there's no charge in the upper right hand corner. And then you'd find out that manganese has got to be +7. Or what you could have done is, by knowing that MnO4 is a polyatomic ion you learned, and MnO4 is -1, you could have said oxygen is -2, there's 4 of them, it's got to add up to -1 in the polyatomic ion. What's manganese? You would have also gotten +7. So those are your oxidation numbers for the first compound. Next, potassium's +1, nitrite right here, NO2 you memorized or maybe could look up, is -1. But let's go through and do them individually. Oxygen would be -2. You can write an equation that says if potassium is +1, nitrogen is some charge, oxygen's -2, and there are 2 of them, it's got to add up to 0 because there's no number in the upper right hand corner. You would conclude that nitrogen would have to be +3 to make that add up to 0, and you would be correct. You could have also said nitrite is -1 and then done the equation to figure it out as well. Hydrogen here is +1, oxygen here is -2, and then maybe you're getting good enough you could do it in your head. Sulfur right here would be +6. Now, how did I figure that out? I could do the same type of equation that I did before. Hydrogen's +1, there's 2 of them. Sulfur is some charge. Oxygen is -2, there's 4 of them, and it's all got to add up and equal 0 because there's no number in the upper right hand corner. So I'd need a +6 right here to balance that out to make it be equal to 0. Okay, what's helpful though is to know that this sulfate right here doesn't change from this side to this side. And you can find sulfate over here in 2 places. And if you know that the sulfate doesn't change, then you're pretty certain that the sulfur isn't going to change in oxidation number. And you can just use -2 right here and -2 right here. And if you forgot that sulfate is -2, you could look it up on the periodic table, and it's right down here, and sulfate is -2. And then you could use that to your advantage because you could say, oh, that means manganese must be +2 right here. And now I can tell that the manganese went from +7 to +2. And so since that went down in charge, that's the thing that's reduced. Down and reduced both start with consonants. And so if you're good at knowing your polyatomic ions a little bit, you don't have to go through all this painstaking part right here. You can recognize that sulfate remains the same, so the oxidation numbers inside of that aren't changing, and it makes it quicker for assigning these oxidation numbers. Water, of course, oxygen -2, hydrogen +1. Hydrogen and oxygen rarely change. And then over here, we can go through and do potassium +1, oxygen -2, and the nitrogen went from NO2 to NO3, so we can't use the polyatomic ions there. We could use it to help assign the potassium, knowing that NO3 is -1, that means potassium is +1. But we're going to have to write the equation to figure this out. If potassium is +1, nitrogen has to be some charge. Oxygen right here is -2, and there's 3 of them, and it's all got to add up to equal 0. Well, that means that nitrogen here must be +5. And there we found our second thing that changed. So nitrogen went from +3 to +5, so it went up in charge, and therefore it's oxidized. So my reduced species was manganese. My oxidized species here was nitrogen. So that was a difficult one. It had a bunch of polyatomic ions in it that you could use to your advantage, but you still needed to figure out some pieces inside, and I showed you a couple of different ways to do each one. All right, let's go down here and let's do another difficult, challenging one. Let's try number 7 right here. So in number 7, we start with a potassium that's +1. And then we have a chlorate, and you'll notice there's not chlorate on this side, so we're going to have to go through and do each individually. Oxygen's -2. There's 3 of them, so that means chlorine must be +5, right? Let's do the math to make sure that that's right. If potassium's +1, chlorine must be some charge, and then oxygen's -2, and there's 3 of them. Has to add up to 0. So this is -6, +1. That means it must be +5 right here. Remember, ignore the coefficients in front, so the 8 doesn't mean anything. Okay, over here, oxygen's always -2, hydrogen's always +1, and if you do the math here, -2 times 11 is -22, and +1 times 22 is +22. Oh, those cancel each other out, which means carbon in this case must be 0. Yep, it's okay to have an oxidation number of 0 sometimes. Over here on this side, potassium's +1, chlorine's -1, hydrogen +1, oxygen -2, carbon must be +4 because oxygen's -2 right here, because oxygen's always -2. Now, what changed? My chlorine went from +5 to -1. And so that went down in charge, and so it was reduced. So my reduced species is chlorine. My carbon went from 0 to +4, so it went up in charge, and therefore it's oxidized. So there I have my oxidized and reduced species. All right, let's do the last one really fast, and I'll go through and assign the oxidation numbers quick, and then see if you can follow along with the whole steps, and then I'll come back and explain it a little bit as well. Manganese is +2. The nitrate right here I notice is also on this side, so let's just leave that as -1 for the entire group. Sodium is +1. BiO3 then must be a polyatomic ion that I've never heard of before, and that must be -1 as a group. Interesting. Okay, now it's probably going to change, so let's split it up. BiO3, a -1 charge. Zoom out just a little bit so I have a tiny bit more room. Bismuth must be some charge. Oxygen's -2. There's 3 of them. It's got to add up and equal, it's got to add up and equal -1. So that means bismuth must be +5 on this side. Okay? I notice that bismuth is with something else on this side, so maybe it's going to change. We'll see. Over here, hydrogen's +1. Once again, I've got the nitrate here. I'm just going to leave that together because it's -1, because over here I have a nitrate, that's -1, and here I have another nitrate, that's -1. So I'm going to assume that those don't change for right now. I can always come back and change it later if I need to. Hydrogen +1. Oxygen right here must be -2, which means my manganese must be +7. Hydrogen +1, -8 right here, I need a +7. And goes from +2 to +7, that goes up in charge, so my manganese is oxidized, because whatever goes up in charge is oxidized, because up in oxidation will start with vowels. Bismuth over here then, since there's 3 of these -1 things, must be +3, and lo and behold, I've found my reduced species right now. Bismuth went from +5 to +3, so bismuth went down in charge, and anything that goes down in charge is reduced, because down and reduced both start with consonants. Let's go through and finish to make sure I didn't do something wrong. Sodium would be +1 to go with the -1, and I have my water here that's -2 and +1 here again, and those are the same as on the other side. So using a few tips and tricks there, you can go through and practice lots of oxidation number assigning, because I know there's a lot of those questions on the test, and you can check your answers as you go along. Even try ones that I just showed you, but maybe wait a half an hour before you try them, and then see if you can do it all by yourself. Good luck with your redox problems.